Learning made easy. Metallurgy for everybody. Introduction to phase diagram. Completely insoluble in solid solution. For the components which are completely soluble in liquid state, there can be three types of phase diagrams for solid solution. First, completely soluble in solid solution. Examples are copper and nickel alloy. Second, completely insoluble in solid solution. Examples are cadmium and bismuth alloy. Third, limited solid solubility in solid solution. Examples are lead and tin alloy. Copper and nickel atoms are near about same size. Both have same crystal structure, that is FCC. Both have complete solubility in each other in liquid phase and solid phase. They combine to form substitutional solid solution. Crystal lattice structure of alloy is also FCC. Here is a phase diagram of copper and nickel alloy. For complete explanation, please watch my previous video. Alloy of copper and nickel are corrosion resistant. Its color is silvery white. It is used for making coins. Other type of solid solution is of alloying element completely insoluble in solid state in each other. They form their own crystal lattice structure. For example, cadmium and bismuth alloy. Cadmium is having hexagonal closed packed crystal structure, while bismuth is having rhombahedral crystal structure. When bismuth is heated to liquid phase, then on cooling, temperature of metal drops up to 275 degrees Celsius. Temperatures remain constant till entire metal is solidified. Again temperature drops and metal cools. Here we have liquid phase above crystallization temperature and solid phase below it. When cadmium is heated to liquid phase, then on cooling, temperature of metal drops up to 325 degrees Celsius. Temperature remains constant till complete metal is solidified. Again temperature drops and metal cools. Here we have liquid phase above crystallization temperature and solid phase below it. These are all the cooling curves for various percentage of cadmium in bismuth and cadmium alloy. As the percentage of cadmium increases, liquid phase to liquid plus solid phase temperature gets lower and lower up to 40% cadmium. Then it increases. Though the solidification starts at different temperature for different percentage of alloying element, but the solidification always completes at fixed temperature. Let us understand the behavior of alloy during the cooling from liquid stage till solidification for different percentage of cadmium, that is 20%, 40% and 80%. When bismuth along with 40% cadmium are heated to liquid phase and cooling curve plotted till solidification, we observe that just like pure element, temperature remains constant till entire metal is solidified. Again, temperature drops and metal cools. Here we have liquid phase above crystallization temperature and solid phase below it. Though it is alloy, but its behavior while solidification is just like a pure element. When alloy of specific composition is cooled from liquid phase, it solidifies at constant temperature to form solid phase without intermediate liquid plus solid phase. It is known as eutectic reaction. In eutectic system, there is always a specific alloy which has a eutectic composition whose melting point is lowest than all other composition. Here, eutectic is a fine mixture of bismuth and cadmium crystals. It is having good strength and toughness. Alloy is heated to liquid phase and cooled. When solidification starts, fine crystal mixture of bismuth and cadmium formation will start. As the temperature falls below eutectic line, as bismuth and cadmium are insoluble in solid phase, separate crystals of bismuth and cadmium will be formed. After completion of transformation at constant temperature, we have eutectic solid phase having mixture of bismuth and cadmium crystals. Alloy is heated to liquid phase and cooled. When solidification starts, fine crystals of primary bismuth formation will start. As the temperature falls further, these crystals grow. When the temperature further decreases, bismuth is depleted from the liquid phase. As the temperature reaches eutectic line, liquid phase components percentage also reaches eutectic composition. Now the eutectic mixture of bismuth and cadmium crystals formation starts. We have bismuth crystals, eutectic mixture and liquid phase. As the solidification completes, we have bismuth crystals and eutectic mixture of bismuth and cadmium crystals. Alloy is heated to liquid phase and cooled. When solidification starts, fine crystals of primary cadmium formation will start. As the temperature falls further, these crystals grow. When temperature further decreases, cadmium is depleted from the liquid phase. As the temperature reaches eutectic line, liquid phase components percentage also reaches eutectic composition. Now the eutectic mixture of cadmium and bismuth crystals formation starts. We have cadmium crystals, eutectic mixture and liquid phase. As the solidification completes, we have cadmium crystals and eutectic mixture of cadmium and bismuth crystals. When alloying element percentage is less than the eutectic composition, it is known as hypoeutectic alloy. For example, bismuth cadmium 50. When alloying element percentage is more than in the eutectic alloy, it is known as hypereutectic alloy. Bismuth cadmium 40 is a eutectic alloy used for electrical and electronics applications, such as primarily soldering in electronic circuit boards, as well as for high voltage or high power applications. If you are interested to watch such videos on metallurgical subject, please subscribe to the channel. Topics discussed are completely soluble solid solution, completely insoluble solid solution, eutectic alloy, phase diagram bismuth cadmium alloy. Thanks for watching.